So if you all go to page 1 of your document, and I'm going to share screen so you see it on my screen as well. So page 1 of your document, and now, oh, hi, Andy. Hi, Rafa. I don't see you, Rafa, but I know you're there, which is great. Um, and also, Andy, if you could turn off your virtual background, because I asked everybody else to do that, because it's distracting to some people, not to everybody, but that's the way I do it. Rafa, also, Rafa, you're in the lower left-hand corner of your screen. If you could center your face so you're centered, like you don't want to be like over there, because then you're kind of behind your name. And that way I can see you, and I can also hear your mouth move. I can see your mouth move. So guys, when I say first quadrant example on this page, can you tell me what it means to say first quadrant? Rafa, please. Oh, and guys, hold on a second, Rafa. Everybody, can you all unmute yourselves? Because
Okay.
if you don't unmute yourself, when I call on you, like when Rafa was trying to talk, he's muted. He has to first hit the unmute button. If you just hit the unmute button, like Alexander, unmute yourself.
Okay.
Unmute yourself. Leave yourself unmuted and do not touch the space bar. Okay, go, Rafa.
First quadrant is the top right quadrant in a coordinate plane, and both x and y are positive.
Yes. So
Also,
guys,
this might be a bit not related, but today's my dad's birthday, so we're ordering takeout at a Japanese restaurant.
that is very related, and I'll tell you why that's related. Because Japan, I think, is in the first quadrant of the world map. So if you think about Japan, it is it is
Oh
east,
yeah, it is.
it's east of the prime meridian, and it's north of the equator. So it puts Japan in the first quadrant, the positive quadrant, positive x values, positive y values. Now, I like to think of a coordinate plane as going to your elevator first, getting in the elevator, and then pushing the button. So for instance, if I go to my 19-sided polygon, which is probably called a non-decagon, and I make a little red dot at that point, you guys see how I first say, hey, get into the 8th elevator. So that's my X value. Get in the elevator and hit what floor?
14.
And so I go right to the point 814. Now, I actually love the first quadrant, and I love places like Japan, and what else is in the first quadrant? What else? I think Israel is in the first quadrant. I think that parts of China, maybe all of China, are in the first quadrant. Omer?
I was born in Israel.
Yeah. So how does it feel to be born in the first quadrant?
I didn't even know Israel was in the first.
Yeah. So I was born, and most of you were born in the second quadrant. So if you were born in North America, you were born in the second quadrant. If you were born in South America, you may have been born in the second quadrant or the third quadrant. So if you were born in, like, say, Venezuela or Colombia, that would be the second quadrant. But if you were born in, let's say, Peru, that would be in the, or Argentina, that would be in the third quadrant. Kind of fun. Now, guys, the real world is not the first quadrant. The real world is 4 quadrants. Go to page 2. Now, if you go to page 2, you will notice that I drew a triangle, quadrilateral, pentagon, hexagon, septagon, octagon, and a nonagon or entagon. And I also named all of the coordinate points that create it. So I'm going to ask you right now, and I'm going to go in a little bit closer. Can you please name this point right here? And please send me a chat. So if you send me a chat right away with your coordinate, make sure that your chat has parentheses around the numbers and the two numbers are separated by a comma. So I already see Rafa, Hannah definitely get this. Adalia, awesome. You guys seem to be in South America right now, but in the Southern hemisphere. Cameron, nailed it. And most people who get this wrong, there's just one little thing that they don't get right. And Isabella, your elevator is correct, but you're supposed to go down 6 floors instead of up. And so, Isabella, you are so incredibly close. Now, the other mistake that people make, would you guys like to see the biggest mistake people make, but nobody has made that mistake today? This is what people do. They write -6, -3. Can you tell me, Hannah, why that is absolutely wrong?
Well, it's the wrong way because it's the x-axis and then I mean, what it is the y-axis and then the x-axis, but it's supposed to be the other way around.
Right. So guys, look at -6, -3. It's in a completely different place. Can you imagine being the pilot of an airplane and you put the coordinates of where you want to go and you mix up the X and the Y? Do you think that would be a good idea?
No, that would be terrible.
Where would you end up?
Be a very good idea.
You would end up in the wrong country. Okay. So I'm going to be getting on a plane on Tuesday for the first time since our little pandemic. And I'm a little nervous, and I hope that the pilots go to the right coordinates. Now, I want to hear from Tessa. Question.
It's not really a question, but when you switch them around, like if it's -3 and like -3, -6, or -6, -3, the two different points, they're 3 like squares like apart, and I think like all of them will be 6 squares apart if you like switch them around.
Whoa. So guess what? We are going to test it right now. So Tessa gave us a challenge. So what I want you guys to do is name this point right here. Please raise your hand electronically and I will call on you to name that point. So go, Cameron.
-10, -3.
Now we're going to do the Tessa test. Okay. Who's going to do the Tessa test for me at -3, -10? And did we find the right point? Now, Tessa, tell me now about your conjecture.
Now it's like, so one of the numbers, so like if it was -3, -6, it's 3 squares apart. But if it's -3, -10, then it's 10 squares apart.
And I'm not going to agree. I see something, Tessa, that is amazing. You have come up with a discovery, Tessa, without realizing it. Do you see what happens when you do 6 minus 3? What do you get? 1, 2,
3.
3. How many diagonal squares are these apart?
7.
What's the difference between 10 and 3?
7.
So guys, can we make a conjecture that if you do this with, so let's say we do this with point, you ready for this? How about 0.2 negative 7? That point right there is 2 negative 7. Let's go find point negative 7, 2, and see if my conjecture works, that we simply subtract the numbers. How far apart are those 2 points?
7.
Well, it should be 5. So far I have 3, 4, 5, 6, 7, 8, 9. Can anybody tell me why they are 9 diagonals apart? Adalia, what do you think?
Because it's a mix of negative and positive numbers.
Now, guys, Adalia might very well be right. But you know what? I am obsessive about testing theories. So can you guys help me test the theory? Let's look at this point right here.
That'd be
Who can name that point? We're going to say it on 3. 1, 2, 3, go.
Negative
Negative
1.
1,
positive 5.
Negative 1, 5. Now, if Adalia's theory is correct, and we go to 5, negative 1, we now have opposite numbers. One is positive, one is negative. And how far should they be apart, everyone?
6.
6.
And are they 6 apart?
1, 2.
Yeah.
So far, so Tessa and now Adalia have come up with a really cool theorem. Now, what if we just do first quadrant? Let's try a number in the first quadrant. How about 7? How about 3, 7? Let's do 3, 7 and 7, 3. And what do you think? How far apart should they be?
4.
4.
And guess what? They're exactly 4 apart. Now, can you guys listen to what I'm going to say right now? And this is true. I am 58 years old, and I have been a mathematician for 53 years. So when I was 5 years old, that's when mathematics came alive for me. All right. Do you know that I have never once explored this question? I've been looking at these graphs for 53 years. And it wasn't until Tessa and then you guys started to make conjectures. That's unbelievable. Really, really cool. But there is something that I do want to share with you. And I'm going to do this with maybe 150%. Let's see if that works. I think it does. I'm going to draw a special line. That line, I'm going to make it nice and thick, and it's going to be pink. Do you see where I started the line from? That line is a perfectly 45-degree diagonal from each of the axes. Can you tell me anything about the lines that we made? And I'm going to make them a little thicker. We did this one and that one, which was 6 apart, and this one, which was 9 apart.
some popcorn?
So who wants to share Who wants to raise their hand and tell me what they see? Do they see anything interesting? Rafa, what do you see?
Every single line is perpendicular to each other.
Yeah, guys, every one of those lines is perpendicular to the pink line that we drew. Now, the other thing that I like to do is I like to create triangles. So if I go and create some triangles with this, isn't that a pretty picture? Now, what if you took the red and you did this? What is happening now to each of these?
They're becoming squares.
Well, some of them are squarish.
Or like,
Or like kite shaped.
Wait a minute, who just said that? Cameron, let us all go to page 4. Everybody go to page 4 and witness Mr. Kramer's absolute favorite diagram or shape of all time. The kite is the most beautiful shape. Now, you guys know that I'm obsessed with kite surfing, so I'm obsessed with kites, but I have always loved the shape of a kite. Now, a kite, I don't know if it was named this because of the toy kite, or if the toy kite was named after the shape. Does anybody have an idea which came first? I do not know. Tessa?
I think it's the shape, because like people been like doing like math for like such a long time. They could have like, and like obviously they could have like made the toy based on that. I wouldn't think that they would like just like name the kite. Wait, no, maybe they name the kite shape after the toy.
You know what, guys? Isn't it really interesting? We probably will never know. Cameron, what were you going to conjecture?
I was gonna think that they came up with the name after the not after the toy, not after the toy, no.
Yeah.
After its shape.
Yeah, I don't know, but I will tell you something else. And I have something really important to talk to you about. The kite has a definition. Who can define the kite for me? Now, I know that Rafa noticed it, but who can give me the definition around a kite? And Andy, unmute yourself. So if I call on you, then you can answer without having to hit any button. So unmute yourself, please. Adalia, what do you think the definition is of a kite?
I don't think this is the definition, but I noticed that every lot, like if you draw a line from each corner, then all the lines except the long one, right? That 6 plus 6 is 12, and the lengths of 3 of the numbers are 6, and the other one's 12.
That is true. That is very true. That's a great observation. That's a great observation. And who can give me a definition though? Because kites can be very, very interesting. In fact, I'm going to draw you a kite right now that I've just been thinking about as we're talking. This is actually going to be a kite. And it's got to follow the definition of a kite. So that is a kite just like the one we drew. And here's the definition. Are you ready for this? Actually, I'm not going to tell you. I'm going to draw it. These two segments are congruent or equal length. and these two segments are congruent of equal length. That is the definition of a kite. So for instance, if we go back here, do you guys see that these two are equal and these two are equal? Now, there's something very special about kites. What is special about them that is only true about one other shape? There's something really special about kites that are only true of one other shape.
Rectangle, but a rectangle isn't a kite.
Rectangles, I will tell you, do not have that quality. The quality of a kite is not shared by the quality of a special rectangle, maybe, but not just rectangle in general. Now, Rafa, you had your hand up? Even though I can't see your mouth. And Rafa, angle your computer down and put yourself in the middle of the screen. Much better. So who has an idea? Oh, by the way, every time I'm thinking about a shape, you know what I do? I start drawing auxiliary lines. And the auxiliary line I want you to draw are the diagonals. Can you please draw the diagonals of this kite? Diagonals are defined as a vertex to a non-adjacent vertex, meaning you can't draw a diagonal on top of a side. It has to go from a vertex to a non-adjacent vertex. What is special about those two lines?
There's only two of them?
Well, that would be true about every quadrilateral, but it's not true of every, but I need something that's true of every kite. And I want to ask Rafa, Isabella, and Andy to unmute themselves. And that way, when I call on you, you can answer. So guys, I'm now going to extend the horizontal one. What did you just notice?
It's directly in the middle.
Yeah, but come on, guys, something very special.
Kind of like the kite
Oh.
shape.
It's on the X and Y axes.
Yeah, but oh, I like what you just said, but the diagonals are what? Come on, say that word.
Perpendicular?
Yes, guys, look at it. They are perpendicular. Now that's true of every kite. So guys, watch this. If I go here, do you see how the diagonals are perpendicular? Now, which other shape has the same quality? And I want you to answer slowly. Think about it and raise your hand electronically. Your job is to raise your hand electronically so I can call on you, and I want diagonals that form right angles. And I'm going to go with Isabella first.
Is it a rhombus?
And guys, everybody look at it. All rhombuses or rhombi will form a right angle for its diagonals. Now, Adalia, did you have something else that you saw?
Yes, but it doesn't work.
What? Let's try it. I always like to try things, even if they don't work. Come on.
I thought the square worked, but when I drew it out, I sort of
Wait a minute.
went against
Excuse
it.
me, but Adalia,
Oh, yes.
what's the definition of a rhombus? Doesn't a rhombus have 4 equal sides? Yes?
Mm-hmm.
Doesn't a square have 4 equal sides?
Yes.
So aren't all squares rhombuses?
Yes.
So isn't Adalia also correct? If all squares are rhombuses, their diagonals must form right angles. Pretty cool? Yes, sir, Cameron.
A rectangle.
Ah, now everybody look at this rectangle. This rectangle is a non-square rectangle. Are those diagonals perpendicular, Cameron?
No.
But if the rectangle were a square, then yes. Does that make sense?
Yeah.
So great. Now, what about the angles of the diagonals of an isosceles trapezoid? Now, notice, guys, that the trapezoid has 2 parallel opposite sides, and its legs are the same. That's why we call it isosceles. Notice the isosceles triangle. Both of the legs are the same. This happens to be a right isosceles triangle. Do you think that you guys could draw an isosceles? So go to page 3 for a second. No, don't go to page 3. Go to page, like the last page in your packet, whatever that is, page 12. Now I want you to try to draw for me an isosceles trapezoid whose diagonals are perpendicular. So you know that the one that I drew for you on page 4, those diagonals are not perpendicular. But I want you guys to pick up your pen and see if you can draw an isosceles trapezoid whose diagonals are perpendicular. I think I can do it. I'm just not sure. Everybody should be writing right now. This is not a thought exercise. Isabella, do you have a question? Okay, unmute yourself so I can hear you.
Well, on page 5, it says create rectangles, squares, rhombus, kite, isosceles, trapezoid, and other stuff. Should we do it on this page or the last page?
Do it on the last page because this one is a special request, Isabella. The special request is that the isosceles trapezoid here has to have perpendicular diagonals. Now, you know that all rhombuses and all kites have this quality, but you can also do it with an isosceles trapezoid, I think. And I'm going to let you guys explore this for a minute. And if anybody has a question, and I also offer you guys, if you draw your diagonals first and then draw the sides of the trapezoid, it might be easier. So think of, because most people will try to draw the sides of the trapezoid first, and it's very hard. Omer, question. You have a question, Omer? Okay, I thought you raised your hand. Sorry about that. And if you have solved this puzzle, please raise your hand electronically so I know you've solved it. Good. And Adalia, and if you have solved it, Adalia, now find the coordinates of your points, please. I'm sorry, of your vertices. The coordinates of your vertices. And I've decided that I'm going to remember to let everybody know when I teach them what we learned earlier. I'm going to call it the Tessa V theory. And I'm going to see if people can make those observations the same one that Adalia made. I think that's really, really cool.
What should I do once I found the coordinates?
Then you can go to page 5 and start that challenge. And I'm going to give you guys another minute, and then we're going to see what you guys came up with. Here we go. All right. So I'm going to ask for Adalia to share with everybody her coordinates. So everybody, I want you to, as Adalia says her coordinates, I want you guys to actually mark those coordinates on your diagram. So I'm going to write them out so you can see them as Adalia writes them. Okay, go Adalia.
0, 0, 10, 0. Wait, yeah. 8, 8. 2, 2, 8.
Okay, so everybody plot those points and let's see if we agree that we've created an isosceles trapezoid with perpendicular diagonals.
I think it would be from the one.
So
That's not how my shape looks.
yeah, so one of your points is, oh, wait a minute, I made a mistake. Can anybody tell me the mistake I made? Did I just fix the mistake?
Yeah.
Okay, good. Now, let's see if that works. Number one, is that an isosceles trapezoid?
No.
I think it is.
Hmm?
I think it is definitely isosceles. And when I draw the diagonals, guess what, guys? They are perfectly perpendicular. Now, I have a process for you that I want to show you. Are you guys ready? Everybody look up at my screen. I am going to draw perpendicular diagonals. Are you ready? I drew them on the y-axis from 10 to negative 20 and on the x-axis from 10 to negative 20. Now watch what I do by connecting these vertices. Do you see how I've created an isosceles trapezoid with perpendicular diagonals? So I actually used the x and y coordinates to help me get there. So we know what, and I hope you guys enjoyed that, and we'll explore that a little bit more. But now, going here, we haven't talked about the parallelogram. Who can define a parallelogram, please? And please focus on the word parallel. Come on, who's got that definition? I know that you should all have it. You should all have it. Hannah, go for it.
Opposite sides that are parallel.
Yes, opposite sides are parallel is the exact definition of a parallelogram. And these little symbols that I'm making, these arrows, if there's two arrows, that means that those are parallel, and these two arrows also. So now what I want you guys to do is I want you guys to go to page 7. I actually had an absolute blast this week creating this challenge. So let's look at the first one. Given point -18, -4 as the lower right vertex of a 14 by 14 square, what is the opposite vertex? So I want you guys to draw it and try to answer that question. If you've already come up with a solution, move on to number 2. These are all really challenging. And Dahlia, do you have a question?
No.
Okay, I thought I saw your hand up.
It's probably from last time.
Oh, no worries, no worries. And I'm gonna make this a little bit smaller now. And I'm gonna look at the point -18, -4. And guys, remember that every box is 2 units apart. Very, very careful. Every box is 2 units apart. Remember, this is the lower right vertex of a 14 by 14 square. So the thing I would do first is draw the square. And then you will easily find the opposite vertex. So I'm gonna now draw the square to make sure that everybody is on the same page, so to speak. Does your square look like this?
Yeah.
Does it look like that, guys?
Yeah.
I'm gonna make it again because. So do you guys agree that this is a 14 by 14 square?
Yeah.
And is that point right there the opposite vertex of the -18, -4? And who could name that point? Omer? Omer, can you name that point?
What point?
Well, so you got to be paying attention. We drew -18, -4. We drew a 14 by 14 square, and we're looking for the coordinates of that opposite point.
Minus, like -31.
Well, it wouldn't be -31 because every square is 2 units. So it's -32 up.
10.
Exactly. Now, let's go to the next challenge. Given that 2 points, -14, 0, and -10, 10, form the upper left vertices of a rhombus. So I'm going to actually connect those 2 points. So those are the upper left vertices of a rhombus. What are the other 2 points? And I think that there are, could there be different solutions to this? Maybe there could be. I actually think there might be 2 different solutions, but it would be hard. Can anybody tell me another vertex that they went to first? Where would you go from -14, 0? Can anybody say it? Go ahead, Adalia.
1 second. -10, 10, -10.
Guys, do you see it? Nice job. Because isn't this, guys, the other vertex? And doesn't that create a beautiful rhombus where the first 2 vertices were the upper left vertices? And so when we name those 2 points, as Adalia said, -10, -10, and then this point, of course, is negative what? Come on, guys, say it out loud.
Yeah. -6.
-6, 0. Now, the next challenge says that a given point, -30, 18, -30, 18, I'm going to make that in green, is the upper left vertex of a rectangle with a horizontal dimension of 40 and a vertical dimension of 4. What's the opposite vertex? Now, I'm not going to draw it. You guys have to, and I strongly recommend that you use a ruler. Because trying to draw a line that is 40 units long, not going to be easy. Well, at least it's not easy for me, I'll tell you that. And anyone who has the answer, you can text it, you can chat it to me.
The horizontal and vertical.
The horizontal dimension is 40 units and the vertical dimension is 4 units. But remember, that point is the upper left. And I'm looking for your chat, which will give that vertex.
And by units, do you mean the squares or do you mean the number?
Well, the squares are only to help us locate. The numbers are what matter. So if the horizontal distance is 40, it is definitely not 40 squares. In fact, we know that that would be 20 horizontal squares. So I'm looking for the first person to chat that answer. And I'm now going to draw a picture. And I hope that your picture looks identical to this picture. Does your picture look like this, guys? Yes or no?
Yes.
Yeah.
Are you sure?
Wait, no.
It shouldn't.
No, mine doesn't look like that.
It should not look like that because I made my horizontal distance 60. Your horizontal distance should only be 40. Does your picture look like this? And
Half.
Omer, show your video, please.
Sort of.
Sorry about that, guys. And guys, do you agree that the horizontal distance I just drew was 40? And do you agree that the vertical distance was 4? Does anybody not agree? Because I'd really like to hear your thoughts about this. And what is that point? You can say it out loud. Nobody has chatted it to me.
14.
Say
I
again.
did.
Oh, you
14.
did?
14.
Oh, yes, I did get one. Thank you, thank you, thank you. It is 10:14. It is 10:14. Did anybody, and can, Rafa, can you put that down, please, for me? Can anybody please tell me why they did not get 10:14? Like, what did your picture look like that threw off the work? Hannah?
At first, I accidentally thought it was a rhombus instead, so I drew a rhombus, and then I looked back and realized, and then I didn't have enough time to.
Ah, kind of interesting. Oh, by the way, would you guys like to have a challenge question? What if I told you that negative 30, negative 30, 18 was the lower left vertex? Then what would the opposite vertex be?
Well, it could.
Who's gonna take that one? Tessa?
Yeah, it would be. Yeah, it would be like higher because.
So what would the exact location be?
Well, like where you put it.
Well, what you have to name it. Come on, you're a mathematician.
It's 22 and
Nope. 22 is the vertical. You always start with the horizontal.
so then it's negative. No, it's 10. Wait,
There you go.
it's 10.
10,
And
comma,
22.
20.
nice. So do you see that if you're going to give me a location, remember, Tessa, you're a pilot. You're taking me to Florida. I do not want to end up in Alabama. Although I think it would be nice to go to Alabama. I want to go to Florida, right? So send me to the correct location. Okay, now I want you guys to do number 4. Number 4 is the hardest one so far. You have point 210, which I'm going to draw in black. You have point 1210, which I'm going to draw in black. And that's the top edge of the parallelogram. What is the height if one of the other vertices is -10, -18? So -10, -18. I've just drawn the third point, and I need the height of the parallelogram. I'm not going to draw the parallelogram for you for at least a minute. And I want you guys to give it a shot. And if you have the answer, please chat to me the height. Rafa, I agree 100%. And Rafa, could you give me the area of that parallelogram while the other guys are working? By the way, I am now going to draw my parallelogram. How many of you actually drew a perpendicular line to show that the height? Anybody want to say it now? Andy, you want to give it a shot? What do you think the height is? And you'll have to unmute yourself, as I always tell you guys to do. Rafa and Omer and Andy need to unmute themselves.
I'm still thinking.
Okay, good. But Andy, remember, that's 10. That's 10. And then, so Andy, what do you think? You have 10, 10, and then something less than 10.
Is it 7?
Pretty close, 28, because each square represents 2. So this has a height of 28. Now, guys, pretty cool stuff. I want to have one little discussion with you. It's more of a philosophical discussion. Can you please just look at my screen? Don't look at what you're doing right now. I want to know if any of you have ever seen a diamond. Has anybody ever seen a diamond, the rock, the mineral called a diamond?
Yes.
Does anybody have one? Like some girls have diamond earrings, or women have diamonds on their rings. Do they look anything like rhombuses?
Well, not really.
Not at all. I want you to look at a diamond, go online if you don't have a diamond in your house somewhere, and I want you to look at it. It looks nothing like a rhombus. So teachers for centuries have been saying diamond when they mean rhombus, and I do not want you to do that, because a diamond is not a mathematical shape. A rhombus is, and it looks nothing like a diamond. Now, it was funny, in the last class, one of my students had a diamond earring. She took it off and she showed everybody, and it pretty much looks like a dodecagon if you look at it straight on, like 12 sides of a polygon. Now, another one of my students, really interesting student, he said, Mr. Kramer, it's kind of like a heart, because a heart looks nothing like your what?
Real heart.
Everybody show me what their real heart looks like right now. Go.
Um,
Show me your hand.
That.
If you hold up your hand, not only is this the shape of your heart, but it's the exact size of your heart. It's amazing. I mean, it's really kind of cool to look at your hand and go, wow. That's what is keeping me going day in and day out. This is some sort of a pictorial that somebody did on Valentine's Day. It has nothing to do with a heart. Okay? Hearts look like this. They're beautiful, but they don't look like that. Rhombuses are not diamonds. They're rhombuses. You guys good on that?
Yes. The average
Okay.
American thinks, average American kid thinks that that looks like a diamond, and that is what your heart actually looks like.
Yep.
And this is such a huge stereotype because, like, really, even the heart, like what you draw, what kids draw, is not. It's not even close to what a real heart actually is. It's not even close. It's literally just like some kid was trying to draw a circle and accidentally messed it up or something like that.
Well, now, guys, it happens to be quite beautiful. Okay, I mean, I have to say that this diagram is quite beautiful, and we could dissect it in another class because there's some really interesting qualities about a picture of the heart. And by the way, did I just draw a kite? Guys, I will see you in a week's time. Have some fun thinking about this and enjoy your week. Bye, guys. Have fun.